Example number 1. Woohoo! Let's say I always draw my fraction bar first. That's just because otherwise it would be crooked. So this is 2x squared plus 12x plus 11 divided by x plus 5. This is your divisor on the bottom. This is your dividend on the top. And so we're going to rewrite this in that format that you probably remember from elementary school. All right. So we're going to take all this and divide it by this. And so the first thing I want to do is I want to take this first part and divide it into this. And so all of this over here, what you're going to see is just my scratch work, okay? So I'm not doing it in my head. So I'm going to take 2x squared and divide it by x, and that's going to give me 2x. I'm going to put that right here. Like I said, I'll come back and I'll explain more thoroughly what I'm doing, why I'm doing it. So then I'm going to take this and I'm going to multiply it by both of these. I'm going to distribute it. So it's 2x times x is 2x squared. And I want to line up the same powers here. Okay, notice how the linear is above that and the squares are below here. And then so 2x times x is 2x squared. 2x times 5 is going to be 10x. Fair enough? Right? Then I need to go back. This is a subtraction. I'm going to subtract all of this. So subtract. 2x squared minus 2x squared is nothing. 12x minus 10x is going to give me 2x. Then I'm going to bring down the next term. Now I'm going to take the x again, the first thing, and divide it into this first thing. So here's my scratch work for that. 2x divided by x is 2. So that's going to go right here. And then I'm going to multiply again. 2 times x is 2x. 2 times 5 is 10. I'm going to prepare to subtract. So remember, when you subtract, you got to change both of those signs. 2x minus 2x is nothing. 11 minus 10 is 1. There's nothing else to bring down. I'm going to use a different color. And that's 1. So this becomes the remainder. And the way we write the remainder is we say plus 1 over the divisor. All right. You used to see that written as like R1, remainder 1. But really what the remainder is a fractional value that doesn't equally divide into whatever you're dividing into. So we create that and rewrite it like that. You could have always written it like that. You just didn't. So again, you're welcome to. So again, what we do here is we set, it's given to you like this. You want to make sure that what you're dividing into goes into the bar, and this is what is going into that if it goes out here. And the first step, you only look at the first two things. We disregard this. How many times will x go into 2x squared? And that's what I did here. I got 2x. This is a single power, so I'm going to write it above the single power to keep it lined up. Okay. After I do that, I'm going to take this and I'm going to distribute it to both of these and 2. I know to put the 2x squared under here because it's squared. I know to put the just plain x over here because it's just plain x. So 2x times x is 2x squared. 2x times 5 is 10x. And then we subtract this whole thing. Really, so it's minus. That goes away, and if this does not drop out into nothing, then you have done something wrong, okay? So just know that. Even though a whole other thing here, something happened, you need to go back. This one starts the next process. And so just do that, and then I bring down the very next term down. Then I do the first thing again. I'm basically done with that now. So now I'm here. So I take the first thing, which is x, and divide it into first thing, which is 2x. Here's my scratch work for that. 2x divided by x just leaves me 2. That goes here. 2 times all of this gives me this. Subtract again. Here, I know I'm done because there's nothing else to bring down. And x will not go into 1. Right?
You're only dividing into the first.
Yes, you only divide the first into the first. And the basic process is just like if you think back to long division when you were little bitty kids, it is divide, multiply, subtract, and then start over. Divide, multiply, subtract. So here's the division, this into this, the multiplication, the subtraction, and then we start over again. Okay, so that's your process if you get lost. Divide, multiply, subtract, start over. Divide, multiply, subtract, start over. Let's do another one. So some important things about these we'll kind of bring up along the way. It has to be in standard form. Standard form, remember, that means start at the biggest exponent and then go down. If it isn't in standard form, you're going to do the whole problem and then realize that it doesn't make sense and you have to start over, and who wants that? Probably no one. Let's see, let's do it again. It's going to be written in a little bit different format, and that's okay. 12x to the third power minus 2x squared minus 20x plus 17 divided by x minus 1. Y'all know why the division sign, it looks like that? You know where that comes from?
It's like a fraction.
It's just like a fraction, right? Like there's something up here and there's something up here, just a side note. When I found that out, I was just like, so first thing I need to do is make it look like this one, right? Because that's kind of how my procedure gets set up. So I'm going to look at this and be like, all right, I got to write it like this first. So let's do that. Oh, straight lines are so hard on here. So then 12x to the third minus 2x minus 20x. If you are not habitually like taking care to line up all your stuff, it will cause you a problem with this, because if stuff starts getting out of line, you forget where to go. So if you're normally like one of my super right brain folks that are just like, you should maybe rethink that for this particular type of problem, okay? All right. All right, so remember, we're going to do the first thing into the first thing. And then here comes my scratch work. 12x to the third divided by x is going to leave me with 12x squared. I'm going to put that above the other squared term, so it's just nice and organized. Then I'm going to multiply this by both of these things and write it here. So 12x squared times x is 12x to the third power. 12x squared times negative 1 is minus 12x squared.
Is the first one always going to cancel out like that?
Yes. All right, remember this is subtraction. And so this will go away, and then negative 2x squared plus positive 12x squared is going to give me 10x squared, and then I bring this down. Now I'm ready to go again. Now I'm going to take the first thing and divide it into this first thing, and here's my scratch word. 10x squared divided by x is going to give me 10x. That is a linear or a variable power 1, so I'm going to put it above the other linear term here, so that's plus 10x. Now I'll multiply it. So this becomes 10x times x, and that's going to be 10x squared 10x times negative 1 is going to be negative 10x. Remember, this is subtraction. This drops out to nothing, so we're on track there, and this will be negative 10x. And then we have one more thing to bring down, so that's how I know I'm not done yet. And now we will go again. So we will again divide the first thing into the first thing. And I'll end up with, my scratch work is negative 10x divided by x. So that's going to be negative 10 this time. So that goes here. And then I'm going to multiply it out again. Negative 10 times x is negative 10x. Negative 10 times negative 1 is positive 10. And remember, this is subtraction, so both of these have got to change. This drops out. I'm left with, what is this? Positive 7. There's nothing else to bring down, so I know this is my remainder. When I have a remainder, I add it as a fraction. 7 divided by what I'm dividing by, what they originally said. And there it is. Questions so far? Okay.
What did you get? Like you. Oh, no.
See it?
Yes.
Okay. All right. Let's do another one. All right, so this will be x to the 4th plus 16 minus 17x minus 17x squared minus x to the 3rd divided by negative 5 plus x. Okay, so the issue with this one is that it's all out of order, it's all out of whack. So we're going to rewrite it first. The first issue is I don't really want it to look like this. I want this to be in standard form. So when I go to write this, I'm going to draw my little thing here. I'm going to write this as x minus 5 on the outside. I just flip-flop the order, right? That's all.
What are we about then, right? So if you wouldn't have flopped it?
Yeah, all needs to be in standard form. Yeah, if it's not in standard form on both counts, the process is not going to work. So, all right, now let's rewrite this. This would be x to the 4th minus x to the 3rd minus 17x squared minus 17x plus 16. Because look at what's going to happen here if you have that negative 5 up front. Your first attempt is going to look like this. I want to divide negative 5 into x to the 4th, and that's not going to do anything for me, right? So instead what we want is it to look like this, and then it's going to kind of work out a little better for us. So you try this one. You give this one a shot. It's long, but it doesn't have any holes in it, and there's not really a new idea being introduced other than this. Then we'll work on one that's missing a term. Did y'all see this in Algebra 2? Yeah, no, yeah, some, okay. Did y'all see synthetic division?
Yeah.
Yeah?
Synthetic's fun.
Oh yeah, synthetic's great. We'll do that in a minute. The only trick is knowing when you can use it and when you cannot. got up here so y'all can see.
Alright, so I have it open for YouTube. What you can do though is on the direct.
This is what you're trying to get up there.
So you can just use the back of your book as your scratch paper and you can turn that in to prove that you actually did it. So if you look at our agenda, we have done this one and you need to do this one. What's gonna happen is use that back to that format with your scratch paper. Once you're done, turn that scratch paper to the box, get your cell phone, pick up the homework.
I can work it out and figure it out.
And then you start on that. You have an hour to complete the YouTube assignment. And again, it may look really, really, long, but that's because I had to fix single problem. You'll notice now that a lot of things fix problems because, tomorrow we're gonna learn something that's called A, that wouldn't let you choose how to, get the end, so let me go ahead and release it for you guys. We edit, you should be able to refresh it. Okay? So again, like I said, it don't look like a lot of questions, but according to Delta Math, it should take you approximately 48 minutes, you got an hour. Okay. Yeah. Go ahead and get started. If you got any questions, please ask. It's just me today, but I will make my way around the room. And back.
Hmm?
Yes, sir.
4x squared times negative 5.
Oh, right.
See, this will be 3x squared.
Yeah, so what you might do is
Yeah.
25 minutes movement, your payment would double everything. That would be great.
2x. Subtract 2.
So when you did negative x to the fourth, is that plus or minus 5x?
So when I did the multiplying, it was minus. But then you subtract all of that. So essentially what happens is you really are looking at, like, let me just kind of pull that little bit out. So if you're actually doing this and I multiply and I get x to the fourth minus 5x to the third, what you're really doing is subtracting that whole thing. So the negative comes inside and then that's why the sign changes every time. Basically, if it starts like getting really big and crazy looking, then the two number one things you do here are you jumble the signs or forget to subtract. Or you lose lining it up or something like that. When it's really nice and clean lined up, it's easier to work through it and not get lost. Most common problem with this is you just get lost in the process. You end up and you're like, I don't even know what I just did. because I got distracted while I was doing it or whatever. So I like to use the color for that reason. I don't care if you like to do that, that's cool too. But you'll eventually, the more you do it, your process will start refining and it'll be less noisy and you'll be able to kind of see where you're at in the steps. So basically, this will kind of be like some problems we've done before where you can expect to try one, get stuck, try another one, make it a little further before you get stuck, try another one, make it a little further before you get stuck, and eventually you'll get one and then you'll start rolling. That's just kind of the way it'll go. Or you'll just have it off the bat, which is fine too. All right. Let's do one that has like a hole in it, right? So this one is, I thought you were raising your hand, x to the third power minus 20x minus 5 divided by x plus 4. Okay. So whenever you are working with these, they have to be in standard form, and if you're having missing powers, you have to put a placeholder in. So this one's going to be written like this. I have a third power. I do not have a squared power, so I've got to do that. And then I can proceed. This is basically nothing, right? But it's got to be there to hold space in the problem when you're doing division like this. So that's the other big place where you're going to get stuck and something's not going to work right. And it will be because you accidentally glossed over the fact that you were missing a power. So let's start this one. So first into the first, here's my scratch work, x to the third divided by x. This scratch work that I'm doing in color is not required. It's just something I do to help me pick through all the noise. So this is just x squared. Now notice if that x squared placeholder would have been, I wouldn't have known anywhere to put that. I'd have been like, what is going on? So x squared times x is x to the third. X squared times 4 is 4x squared. Notice that's positive and it's about to turn negative because I'm subtracting it. So subtract, subtract, and this becomes negative 4x squared. I'm going to bring something down, and then I'm going to go again, first into the first. Here's my scratch work for that. Divide that by x, I end up with negative 4x. That goes here. I'm going to multiply again, negative 4x squared, negative 16x.
Well, the first day it was funny.
Now I got to subtract, so these two signs will change. This will be negative 4x. Got to bring something down every time I do that. And now I'm ready to divide first into first again. And I just have negative 4. Multiply again, negative 4x, negative 16. Those look like it's not going to work. And then I remember, oh yeah, I'm subtracting, so I have to change the signs. And this will be 11. That's a remainder, and I know that's a remainder because there is nothing left to bring down here, and so I will add or subtract it as a fraction that I make with the original divisor. Yes,
So the remainder can be negative?
it can. If the remainder is negative, then you would just subtract that fraction. Like if this was a negative 11, this would be minus 11 over x. Yes, ma'am. So the 0x squared comes from where I have to have everything, all powers that are in the middle. Like there can't be a hole. So I need 3, 2, 1, 0. I didn't have one, so I had to put a placeholder in. So anytime that there is a power missing under the higher power, it's got to go in as a 0, blah, 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 just to hold space. Because otherwise I wouldn't have had anywhere to get all this from. All right. Okay, let's do one more like this and then we'll do some synthetic or something. I don't know. I think we'll do synthetic next. Okay. Yeah, this one's gross. Let's do this one. All right. Let's do 4x to the fourth plus 16x to the third plus 11x squared minus 16x minus 2 divided by x squared plus 4x plus 3. So let's first check for standard form and no gaps. 4, 3, 2, 1, none. 4 or 2, 1, none. So we're good there. This one's just going to be drawn out, but fear not. It is the exact same process as we have already been through. It's just more complicated, more steps. 4x to the fourth plus 16x to the third plus 11x squared. This one does something like special at the end, and I just want you to see an example of what you have to do here. So once we've got it set up, there are no holes, there's no gaps. It is in descending exponent order. We're just still going to do first into the first. Same exact thing. Divided by x squared. So this time I just start with 4x squared. If you remember that you match the powers when you put it up here, you'll know where it goes. It goes right here. And then if you remember at this step, when we distribute or multiply, we multiply it by everything over here. So we're going to just do that again. Now there's just 3 of them instead of 2. So 4x squared times x squared is 4x to the fourth. 4x squared times 4x is 16x to the third. 4x squared times 3 is plus 12x. Remember to subtract, 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 subtract. So this time both are going to drop out. That does not necessarily always happen. It just happens this time. Like this goes away and this goes away because 16 minus 16 is 0. Then I have 11x squared minus 12x squared. So that's just going to be negative 1x squared. And then I bring something down. So notice the process itself is not changing if we know what we're doing and why we're doing it. Next thing I just brought that down, so I'm going to multiply everything again. So this is 4x squared. Oh, what? Hold on, lost. Hold on, lost. Yeah, thank you. That'll happen sometimes because look, I lost my train of thought. I was ready to do this again, but I was like, where is it going to go? So when you're doing that and something doesn't make sense or you get lost, it's probably because you either went back a step, went forward a step, or somewhere in the process that is incorrect. Happens to the best of us. All right. So let me look at it again. I need to divide first by first now. Yeah? Okay. So let's do that again. That'll be negative 1x squared divided by x squared. Well, this is just negative 1.
We put a placeholder in there.
You still just put this right here, right? You still put it right there. Remember what I said. You could put a placeholder because like we just leave it. You could put plus 0x or whatever, that's fine, but it's the same thing in the wash. If you just remember that you put it there, I don't put it here because it doesn't have an x. I line it up right here, and then I just follow the same process. Let's see how it goes. So negative 1, this is negative x squared. This is negative 4x, and this is negative 3. Plus, plus, plus. That goes away. What does this end up being? Negative 12x. What are these two right here? It's gonna be plus 1, right?
Oh,
You see it?
yeah.
We just didn't get a chance to bring it down to include it in the division, but that's just because we can't divide anymore.
Did you bring it down?
I never got a chance to
Wait,
because
where's the plus 3 from again?
plus 3 is negative 1 times positive 3 equals positive 3 or negative 3. And then we subtract, so it becomes positive 3. But then we also have this hanging out up here. It can't be brought down anywhere, so we just add it up. Well, this is your remainder. Plus negative 12x plus 1 over x squared plus 4x plus 3. That's why I said this one's super gross and nasty. This will not be the norm. I just wanted you to see it. But this is not what like the normal problem you'll see with this looks like, but it can occur. So you kind of have to be like, well, what do I do now? Because look, I mean, if you bring this down, where's it gonna go? I mean, there's nowhere to bring it down because you're done at this point. So but we can't just disregard it. So we have to add it up. You can't just pretend like it's not there, but it's also not going to follow this process, right? Because normally what I would do here is I would get this done and then I would bring this down. I mean, if it makes you feel good, you can just bring it down at this point, but I mean, it's all the same. You're not going to be able to bring it directly down and begin the process again because it's over. How do I know it's over? Look, there's nothing else to do up here. I'm already at the end. Okay. This remainder is hideous, but it can happen this way. Okay. Questions about this one? Nope. Oh, fantastic. Fantastic. Okay. So here it is. That was fun. All right. I just like the screening of things. It's bizarre. Okay, let's do some synthetic. So a couple of notes about synthetic division. Slightly different process, and if you want to kind of make a sub-heading in your notes, this is synthetic division. Synthetic's down here. Long division was up there. Now I'm going to teach you synthetic, but it only works sometimes, and I'm going to explain when it works after I do one, okay? If I explain it now, y'all aren't going to remember. All right, let's do 2x squared plus 12x plus 11 divided by x plus 5. Now this is straight memorized procedure, okay? So I'm going to go ahead and do it, and then I'm going to explain what I did. So we're going to do this, just see if you can figure out what I'm doing, and then I'm going to explain what I'm doing. Okay. That's your answer. 2x plus 2 plus 1 over x plus 5, which is much more fun than what we did before. All right. So this is kind of a shortcut. Again, it's just a procedure. So what I did is I wrote this little upside down division bar. I'll solve this for 0. X would equal negative 5 here. So that's what goes on the outside. And then I just took the coefficients from the standard form of what we're dividing into, and I wrote them here in a line. Just the coefficients. I don't care about the variables. Just the coefficients. I just brought this one straight down. Didn't do anything to it. Then I multiplied this one times this one, and I added. have 2. Then I multiplied this one times this one and put it here, I added again and got 1. And because it's division, it's gonna drop by 1 degree. So whereas we started with this polynomial of 2nd degree, this quotient, or the answer, goes 1 degree down. So the first variable is to the power 1, not 2. So this is power 1, this is power nothing really, and this is just the remainder. Just much, much faster, much more efficient. But the kicker here, and the only time it works, is if this is linear down here. That means this has to be a power 1 with nothing in front of it. Coefficient must be 1, it must be x to the 1. If it's x squared, you cannot use synthetic. If it's 2x, you cannot use synthetic. Okay. Gotta just be a x plus something or minus something. Let's do it. The placeholder rule still applies. If you're missing an exponent in descending order, you have got to put a 0 there, or you're going to be wrong. And who wants that? All right, let's do another. We like this better? Everybody always likes this better, and they're like, why did you even show us the first one? And because it doesn't work all the time. All right, so let's do another example. This would be 12x to the 5th minus 4x to the 4th minus 12x to the 3rd plus 14x squared minus 22x plus 19. Where my pen go? There. And then all of this divided by x minus 1. So to prepare for this, I'm just going to go ahead and write my upside down bracket. Let's check and make sure there are no holes in this. This is 5, 4, 3, 2, 1, none. Excellent. So we can just bring these coefficients down. So this will be 12, negative 4, negative 12, 14, negative 22, and positive 19. Here's the number one mistake that people make with synthetic. And I'm going to write in red what is wrong, and I'll do it correctly in black. People do this because that's negative. That is no. This is a positive 1. It's the opposite sign of what you see here. Because essentially what you're doing in this process, and we'll see more about this later when we factor using synthetic division, is this is actually solved for 0. So again, the first one just comes straight down. Don't do anything to it. Then you're going to multiply this times this, and it goes here. Now the difference here is that you add, not subtract. In the long division, we subtract every step. Here we add. So this will just be 8. Then we multiply this again. 1 times 8 is 8. We add negative 4. 1 times negative 4 is negative 4. And then we add again. 10. 1 times 10, positive 10. Add again, negative 12. 1 times negative 12, negative 12. Add again. I like Sal. He does a really good job. I learn a lot from him. Let's see. We need to put it back together now because this is your quotient. This is your quotient or your answer. The answer to a division problem is just called a quotient. And so if this begins at power 5, this will begin at power 4. This will become power 3 minus 4x power 2 plus 10x minus 12 plus 7 over the original divisor. And there you go. Yes. Oh, yeah. All right. Yes. Yeah, all right. All right.
That's the freshman year agenda. The dates are all scrambled.
This is lame. What is this?
This is my freshman year agenda.
How do you even hold up? People can't hold on to these for like 2 days.
I know.
What day is it? I'm so confused.
It's on.
This is trash.
Tuesday.
This is- I'm proud of you for not losing it. Excellent job. Better than I can do. Here, I'm too confused. Just go. That's fine. I can't do it. I just completely broke my entire mind. I can't. All right. Synthetic division, how we feel? Yes, ma'am. So when you divide, you go down by 1 power because we divided this one out. So every time you use synthetic division, the quotient will go down by 1 power so that your answer will be a degree lower than your original. Okay. Let's do one that's got a hole in it. Let me see if I've got one. Let's see. I have an example in here that has a hole in it. If you have a hole in there, put a 0 as a coefficient. We got that? I don't have one right here. Do you want me to find one and do one? I can do that. Yeah. Okay. Give me 2 seconds. Just be patient. I thought I had one on there. I do not. I don't see one. But I will gladly find one. Polynomials, dividing polynomials. Notes. Let's see. Sure. Ah, there's one. Okay. Let's do one that's got a hole in it. So this one would be example. It's going to be 6x to the third plus 16x squared minus 11 divided by x plus 2. So this we've got 3, 2, but we're missing the variable with power 1. So we'll go ahead and set it up. Oh, that was tragic. Here we go. All right. So this would be 6, 16, 0, negative 11. Because notice I'm missing the first power of x. So that would be like plus 0x. We need that placeholder for the linear term. What number goes out here? Negative 2. Very good. Not positive 2. And we're going to bring it down. 6. We're going to multiply. Negative 12. Add. That's 4. Negative 2 times 4 is negative 8. 0 plus negative 8 is negative 8. Negative 2 times negative 8 is negative 16. Positive 16, my bad. And so this would just be 5. Remember, we dropped 1 degree, so the original degree is 3, so this will be 6x squared plus 4x minus 8 plus 5 over the original divisor. Make my remainder. So without the 0, wouldn't have had enough, and we would have lost this completely, and this number would be off. If this is 0, of course you don't have to include it. Does that make sense? All right, one last thing. one last thing. So this is called the remainder theorem. The remainder theorem. All right, so what I want you to do in this one, I'm going to let you do something first, and then I'm going to show you something. So let's say I have f of x, some function, f of x 2x to the fourth plus x to the third minus 3x squared minus 6x minus 1. Let's say we have some number k, -1, and my instructions are evaluate f of x at. So when I say evaluate, that just means plug in, right? So what's k? -1. So evaluate that function at -1. So let's do that real quick. And if you don't remember how to do that, you just plug in -1 everywhere you see an x. And then it's just a number. You're just going to get a number. So essentially what you're looking for is f of -1. And to do that, you're going to plug in -1 for all the x's. So that'll look like this. 2 times -1 to the fourth plus -1 to the third minus 3 times -1 squared minus 6 times -1 minus 1. And you should get 3. Make sure you get 3. Got it 3? Yes. Good. Okay. So let me show you how I do it. And this is the way I want you to do it after this. 2, 1, -3, -6. There we go. 2 is -2, so that's -1. This is +1, -2. 4, +4, 3. So what the remainder theorem says is that I can evaluate a function at a specific value using synthetic division, and the remainder is the value of the function evaluated at that number. So instead of having to plug all this in, you can just take this number and put it here. And you can just do synthetic division with all of these numbers like we did before. Except your answer isn't the whole thing, right? So we just took these and put them there, just like we were about to divide it or something. The remainder theorem says that the remainder itself is the value of the function evaluated here, right? Which is just like, blows my mind, to be honest with you, like how in the heck that even works. Because those two things seem to be unrelated. But that's another use of synthetic division. You just set it up like you're going to divide it. And the remainder is what you would get if you plugged it all in and plugged it in your calculator. Seems unrelated, but isn't. Let's do one more. The only thing you're gonna have to remember, what is different about this process? What's different here that you anticipate that you might mess it up? What do I normally do from here to here? I usually switch the sign, but I don't when I do this. Okay. So that's a sticking point you'll need to remember. All right, so when using the remainder theorem, you just carry that straight down here. Let's do one more, and then that's really all I have for you today. The rest of your stuff, you'll have an assignment on Delta Math. Your favorite thing ever.
Wait, can you go?
I can. Let me write this real quick. So you can do this. Or you can do this. You can do all of this, or you can do this, and you'll get the same exact result.
Are we still using -1? Are we still using -1?
Hold on. Let me tell you what to use. So let's say K is -2. So evaluate f of x at K. Good. I'm gonna let y'all try this one.
Example, if we do like that on the bottom right there,
The bottom one.
the one we have blue circle 3.
That's just the answer.
Yeah, no, so for that one, like if we're doing that, form for the, no problem for -x, we just put -1.
Say it again.
Are we putting like -1 for the x's? If we're doing like the L thing,
You're gonna evaluate at -2 here.
I don't know, for -x, do we put it for just the x?
Where's the, oh, what's the coefficient of that?
We-
-1. Yeah, I just didn't understand what you were asking. You should get -16 for this one.
That's what I'm.
Yep, you got it. This one should be -16. If you didn't get -16, I can guarantee what you probably did is didn't put a placeholder. This would be 3, 0, -1, and 6. So it'd be 3, -6, -6, -12, 11, -22, -16. And if you're unsure if you did it right, you can always go back and check yourself. So this would just be -2 to the third power minus -2 plus 6, and you'll still get the same thing if you plug that in your calculator. And that's just the remainder theorem. Questions? Feel pretty good? All right, let me post your Delta Math for you. That's just for your practices today. There's some long division. No notes required. This practice is for you. If you struggle with one, I would suggest writing the original problem down so I can help you with it. I should be able to go back in and pull up whatever problems you did, but just still. All right. Let me post this for you. Edit. we go. So you should just be able to, you can either go directly to Delta Math or you can go through Google Classroom and it's got a direct link to the assignment for you. Whichever you prefer is good for me.